Alright, what's up guys? Mr. Fabella back here with another video continuing our work with inequalities. So last time we worked with writing inequalities, what they were, and graphing them. So today we're actually going to be solving one-step inequalities, and we're not even going to go too far into the super confusing parts with negatives. So yeah, we're going to be writing and solving inequalities, graphing them, and also interpreting them. Like, what does it mean after solving one? So let's get started here. Okay, so we have solving inequalities right here, and there's a difference. We've already done solving equations. Now we're going to be solving inequalities. So I want you to think back to when we were solving one-step equations and what we did. So solving mentally, a lot of you guys do this anyway, but I try to emphasize to show your work because it's going to be more beneficial when we do two-step inequalities or three-step or multi-step inequalities or equations. All right, so solving mentally, if you're looking at this and you're like, okay, x plus 3 equals 5, what do you add to 3 to get 5? So you can do that mentally, x equals 2, right? For inequalities, x plus 3 is greater than 5. So you have to think, what number can go in x where if you add it to 3, it's going to be a number greater than 5. So x is any real number greater than 3. A lot of times maybe that's not what you automatically think of. Maybe that's not what you automatically think of when you're doing this, but x is any number, so it could be 2.5, it could be 8, it could be 3,792, it could be 2.0001. That's any real number greater than 2. If you plug it in to x, it will make the inequality true. For this equation on the left side, only x equals 2 is the only number that if you plug it in, it gives you a true statement. For inequalities, any real number that's greater than 2, so an infinite amount of numbers, you can put in there, and it will give you a true inequality. So going on to using transformations, so using transformations, that's just a fancy way of saying show your work. Whatever you do to one side, do to the other side. So for example, x plus 3 equals 5. You do the opposite. You use the subtraction property of equality. 3 is being added to x. You're going to subtract 3 from both sides. And then you're going to end up with x equals 2. So the same thing works with inequalities. It's actually the exact same thing. Solving inequalities is exactly the same as solving equations, except for one exception that we're not even going to do in 6th grade. And that's when you're multiplying or dividing by a negative coefficient. So for this, you just treat it the same way. You just have to be very careful about keeping the symbol the way it is. You're not supposed to be switching it, and you don't want to do the common mistake of just putting an equal sign there. So here, same thing. You're going to subtract 3 from both sides. X is going to be greater than 2. So you have to make sure that it's the greater than symbol, because if you're going to graph it, that's the case. And also if you put an equal sign there, that's actually completely untrue, because x can't eat it. You're not allowed to have x be equal to. If you put 2 there, 2 plus 3 is equal to 5. It's not greater than 5. 5 is not greater than 5. It's equal to it. So that actually would be not just a little incorrect, it would be not correct at all. All right, so let's move on. All right, so using addition and subtraction properties to solve inequalities. So we kind of just went through it very fast. We're going to use the properties of equality and properties of inequality. So it's saying the same thing. Whatever you do to one side of an inequality, you do it to the other side, just like solving equations. So for example here, 5 is less than 9. That's a true inequality. If I add 4, the same number, to both sides, the inequality will stay true. 9 is still less than 13. And you can pick whatever number you want. If you subtract 3 from both sides. So you start off with 11 is greater than 6. If you subtract 3 from both sides, 8 is still greater than 3. You can pick any number you want. You could start with any inequality you want. And if you add or subtract the same number to both sides, the inequality will stay true. All right. And yeah, properties are also true for less than or equal to, greater than or equal to. All right, so let's get started with one example here. Solve for x plus 7 is greater than or equal to 10. Graph it on the number line. So I'm going to be using transformations. So x plus 7, I'm going to rewrite it, is greater than or equal to 10. Okay. Here, I'm going to do the opposite. 7 is being added to x. I'm going to do the opposite, which is subtract. Subtracting 7 from x gives me just x, because 7 minus 7 is 0. And this is 3. And make sure that this is x is greater than or equal to 3. Okay. And then graphing it. So you have to recall greater than or equal to, that gives you a closed circle because it can be that number. So if I'm going to graph this, it's going to be at 3, greater than or equal to is going toward the right, and I'm going to write an arrow because it goes on infinity there, and making sure that it's a closed circle. So any number that falls within that arrow's range will make this inequality true. Okay, here, solve n plus 2 is greater than 8. One thing I wanted to mention though, I doubt that you might do it, but just in case, if you rewrite it, you write it like that, right? Unlike in equations, you can't switch around the sides just like that. You can't go 8 is greater than n plus 2. Can't do that because the inequality is not true anymore. If you think about it, if this was, let's say I had 5 is greater than 1, you can't just switch it around and go 1 is greater than 5. The inequality would have to switch around too. 1 is less than 5. So we're not exactly there yet, but I just wanted to mention it in case for some reason you wanted to switch it around. All right, so here your n is being, 2 is being added to n. So I'm going to subtract 2 from both sides to undo that. And then I get n is greater than 6. And if I'm going to graph it, and all I really need is the number that I'm graphing is 6 and put it on the right side of 0. And now I can graph this is greater than, and it's an open circle because greater than means it cannot be 6. It can be anything larger than 6, but it can't be 6 itself. Okay. All right, so that's the graph, and n is greater than 6. You can always check your answer by picking a number that would fit here. So like, let's say 10 is greater than 6, right? So if I put in 10, 10 plus 2, is that greater than 8? 12 is greater than 8. So yeah, you did it correctly. At least your inequality is correct. Okay, moving on to the multiplication and division properties of inequality. Exact same thing as multiplication and division properties of equality when we're solving equations. So if you have an equality, 5 is less than 10, if you multiply both sides by 2, you get 10 is less than 20. It's still a true inequality. Same goes for 16 is greater than 12. That's true. So if I divide both sides by 2, I get 8 is greater than 6. So it's still true. So let's take a look at this. I always like to rewrite all of this. 5x is less than or equal to 45. Right? So 5 next x, 5x, that means 5 times x. So the opposite of multiplying by 5 is dividing by 5. So usually we show it like this. And then because it's nice to see that 5 over 5, that cancels. And you just are left with x, and this is 9, and the inequality drops down. So x is less than or equal to 9. So again, you are going to graph it, put the 0 there, put the 9 there, and less than or equal to. So or equal to is a closed circle, less than is going to be to the left. And 3x is less than 21, same thing. X is being multiplied by 3, so I'm going to do the opposite of that, which is dividing by 3. And this is 7. X is less than 7. So we're going to, whoops. So we're going to have 0 here, we're going to have 7 here. Less than, there's no equal sign, so it's an open circle, and less than means it's going to the left. So any number to the left of 7, not including 7, will be a solution to this inequality. And now, this is x over 8, which is the same thing as saying x divided by 8, like some number divided by 8, is greater than 3. Okay. So here, x is being divided by 8, so to undo division, you multiply. So I'm going to show that by saying I'm going to multiply by 8 here, multiply by 8 here, right? And then you can see that the 8's cancel, because this is like 8 over 1. Right? So this is just x, and this is going to be 24. So greater than stays there. If I'm going to graph it. I just need the 0 here, 24, and greater than, so it's an open circle, and going to the right. Again, if you're graphing it, you don't have to put 24 little tick marks on one side, but generally you want to have 0 as a reference point. So this is a completely fine inequality or a number line. Okay, Laverne is making bags of party favors for each of the 7 friends attending her birthday party. So 7 friends attending her birthday party. She does not want to spend more than $42 on party favors. Write and solve an inequality to find the maximum cost for each party favor bag. So let's start with, this is a word problem and it's dealing with variables. So let's declare a variable. So let's say that C, so I'm going to say let C equal, okay. So she has 7 friends. So 7 friends times the cost of each bag. She does not want to spend more than $42. That means she can spend $42 or less. So which inequality is that? She can spend less than that or $42. That would be less than or equal to 42. Okay, so that's our inequality. To solve it, I'm going to divide both sides by 7. Inequality stays the same, and that's going to be 6. To find these, okay, so we have to interpret this. So that means the cost of each bag can be $6 or less. All right, so there you have it. This is a little review on inequalities. Very, very similar to solving equations, one-step equations. Hopefully that was helpful, and I'll see you guys next time.